Hello everyone. So in this lecture we are going to discuss about digital to analog converter. So far we have studied analog to digital conversion. We learned how an analog signal can be converted into digital signal through sampling, quantization and encoding or coding. So now we'll study the reverse process. A DAC, that is digital to analog converter, takes the digital input and produces a corresponding analog output. So this is important because many real world systems ultimately need analog signals. For example, after digital processing, we need a real-time signal. So that is possible by converting the digital signal back to the analog waveform. So the presentation introduces three techniques for digital to analog conversion. They are sample and hold technique, first order technique, and linear interpolation with delay technique. All these three techniques are approaches for producing an analog representation from discrete digital samples. We will understand the basic operation of each technique. So let us begin with the sample and hold technique. The basic idea is quite simple. The digital input is first converted into corresponding sample values. This sample and hold block then holds each sample value for a specified period. So as a result, the output waveform remains constant between two consecutive sample instants. Therefore, instead of immediately changing from one sample value to next, the output holds the current value for a certain duration. So this produces a step-like or a staircase waveform. So that is what shown in this slide. Now look at the block diagram. We have a digital input signal. It is applied to the digital to analog conversion process. The output then passes through the sample and hold stage. The resulting waveform is then applied to a low pass smoothing filter. Finally, we obtain an analog output signal. The smoothing filter is important because the output from a sample and hold operation contains abrupt transitions. The low pass filter smooths these transitions and produces a waveform that is better approximation of the desired analog signal. So overall, the process is digital input, DAC, sample and hold, low pass smoothing filter, analog output. So before moving to first order hold, let us understand the waveform conceptually. Suppose the first sample has a certain amplitude. The sample and hold circuit maintains the amplitude until the next sample arrives. When the next sample arrives, the output changes to a new value and holds that value. This process continues for every sample. Therefore, the output has a staircase appearance. The advantage of this technique is its simplicity. However, the staircase waveform is not exactly the same as the original smooth analog waveform. Therefore, a smoothing filter is generally used to obtain a smoother output. Now let us move to the first order hold technique. The sample and hold technique keeps each sample value constant until the next sample. In contrast, a first order hold provides a changing output between consecutive samples. Instead of maintaining a constant value, the output changes gradually from one sample value toward the next. Therefore, the resulting waveform is more like a sequence of straight line segments rather than a staircase waveform. So this provides a better approximation of a smoothly varying analog signal compared with a simple zero order or sample and hold type output. So the key idea to remember is sample and hold produces a constant value between samples, whereas first order hold produces a linearly changing value between samples. So you can understand this with the diagram shown in this slide. We'll move to the next technique, the third technique. So the third technique introduced in this presentation is linear interpolation with delay. Linear interpolation with delay. The basic idea of linear interpolation is to estimate the values between two known samples using a straight line. Suppose we have two consecutive samples. Instead of keeping the first sample constant until the second sample arrives, the interpolation process creates immediate values between them. These intermediate values follow a straight line relationship. The technique also includes a delay, as indicated by its name. Therefore, the output waveform consists of linearly interpolated segments between the samples. This provides the another method for obtaining smoother approximation of the desired analog waveform. So that's all about ADC. So we have seen three different techniques: sample hold, first order, linear interpolation with delay. So let us now compare these three. So in the sample and hold technique, each sample is held constant until the next sample. Therefore, the waveform has a staircase shape. We can see here. In the first order hold technique, the output changes linearly between consecutive sample values. Therefore, the waveform consists of a straight line segments. In linear interpolation with delay, intermediate values are generated using linear interpolation together with the delay indicated in the technique. So therefore, the waveform can provide a smoother representation between samples. The important difference is how the output behaves between two consecutive samples. So overall, let us connect what we have learned with respect to ADC and DAC. An ADC converts an analog signal into digital form. The main stages are sampling, quantization, coding. An ADC performs the reverse operation by taking digital information and producing an analog representation. In practical systems, ADCs and DACs are often used together. For example, an analog signal can first be converted into digital form. The digital signal can then be processed, stored, or transmitted. After digital processing, a DAC can convert the information back into an analog signal. This ADC-DAC combination is fundamental to many modern digital electronic systems, also analog electronic systems. So let us summarize. So summarizing ADC, it has three stages: sampling, quantization, and coding. On the other hand, DAC, it has three techniques: sample and hold, first order hold, linear interpolation with delay. So therefore, overall signal conversion chain can be remembered as analog signal, ADC, digital processing, DAC, analog signal. So this completes the discussion on ADC and DAC. I hope you understood and clear about ADC and DAC. So thank you for watching this lecture.